Hi, this is Tim. Today we're going to talk about the effect that input filters can have on your high-speed counter. In our last several videos, we've been talking about high-speed counters. We've gone through how to wire them. We went through this craziness here to describe how counters actually track direction and position. And then in our last one, we talked about how to calculate rate. But one warning I gave you in the first video was to make sure you remember to lower your input filters. So in this video, we're actually going to bring our input filters up to the default, and we're going to start playing around and see what pitfalls are when we start seeing problems. For this video, we're using our PLC trainer with the Micro850 on it. It also has the HMI. We've relocated the HMI on this one. And the PLC tools Sim, EOC, Encoder Simulator. That is what's simulating our encoder. That way I don't have to sit here and spin this forever. And we're gonna use the same program that we left off with. We're just gonna disconnect from it, and then we're gonna double click on the Micro850 in the root of our configuration and go down to our embedded IO. And right here, we've lowered these input filters here. And what we're gonna do is we're gonna bring these back up to their default value. First, I did not think to look up what their default value is. Let's try the F1 key and just see if maybe it says it. Doesn't look like it really quickly. Oh, there we go. You gotta love the F1 key. I gotta admit, that's something they've just done an excellent job in the Connected Components Workbench software. But so our default is going to be 8 milliseconds. So that's where we're going to start at, is 8 milliseconds. So we have both of those at default, and we're just going to download the exact same program. Okay, so we're back online, and yeah, our high-speed counter rate is 40, just like it was when we left off, because yeah, we were at 10 Hertz on our encoder simulator, and we're at 40 here, which if you remember from, I think, the second video, a quadrilateral encoder is going to count 4 times the frequency, and so that looks great. Now what we're going to do is we're going to increase our frequency to 100 Hertz. We'll click that, and our rate went to 0. So what happened there? We were at 10 Hertz, looking good. We go to 100 Hertz, and everything flops down. And guys, you'd be surprised the times that I've actually, well, one, that I've done this, but also that I've gotten calls about this. They're like, hey, we got a new machine and it runs great at slow speeds, but the more we speed it up, the worse it runs, which could mean a lot of things, but a lot of times it is these input filters. The issue is we've set those for 8 milliseconds, and that means that an input has to be on or off for 8 milliseconds for it to count. Now, we're not losing counts here. Our rate is at 0 and our accumulated value is not moving. And the reason for that is we're now at 100 Hertz. And 100 Hertz means that we're going to be turning on 100 times in a second and off 100 times in a second, which is going to be a total of 200 transitions. So you have 1,000 milliseconds, you divide it by 200. That means our transitions are 5 milliseconds wide, but our filters are 8 milliseconds wide. And so they're not going to ever catch anything. So let's go back offline and go back to our filters. And so instead of the default filter, what is the next one up? Well, let's do some math. Yeah, that should work with 4 milliseconds, right? Let's set 5. I don't know, this will be interesting because this one's gonna be right on the edge, but let's go with a 4 millisecond filter. We only need to do that to input 0 and 1 for this. And let's download that program. Oh, and bam! Our counter shoots right up to 400, which is exactly where we should be. So 4 millisecond filter and 5 millisecond pulses does work. But now let's switch our frequency. Our next one is going to be 1 kilohertz or 1,000 pulses per second. And yes, our rate is going to drop back down to 0 and our counter stops counting. And that's because, okay, we're at 1 kilohertz, that's 4,000 pulses per second. That means that the pulse width is going to be 1/4 of a millisecond. With a 4 millisecond filter, it's never going to see those 1/4 of a millisecond transitions. So let's go back offline and go back to our input filters. So we know we need to be somewhere around 1/4 of a millisecond. Okay, and we have 1/4 of a millisecond. Now this is going to be interesting because we're going to be sending it pulses every 1/4 of a millisecond. We're going to put 1/4 of a millisecond filter on it. So I get the feeling this thing should show 4,000 on a rate. I think there will be some misses, but let's try it. So we're going to download that. Okay, and our rate is going up. Oh, okay, so I was wrong. If you have 1/4 millisecond filter and you're sending it pulses every 1/4 of a millisecond, it looks like it does do decent. But now let's switch it to 10,000 hertz. And once again, you're going to see our rate go down to 0 and our counter is not going up. So now let's go ahead and drop that on down just to show what it should look like. And let's go back to our IO configuration. And typically I do drop it all the way down to 5 microseconds because I kind of figure that once you're in a high-speed counter application, you're going to be using quality power, quality components, quality shielded cable. And that's going to keep the noise that these filters are for out. And we'll download it. Okay, and immediately our count goes up to right at 40,000 hertz, which is exactly where it should be. So I hope that's helped you understand how the filters work and what they do in a PLC. Now, I don't know if I actually gave the purpose at the beginning. So normally what your filters are doing is trying to filter out noise, but there is almost no difference. In fact, I don't know if this is going to show up, but I put a graph of this down here. And really, if you're looking at a graph of this, it looks like noise. So it's hard for it to determine the difference between noise that it's filtering out and these high-speed counter pulses. So that's why you have to drop those filters down and just use good quality wiring practices. So I hope this video has been helpful. I think we've covered the high-speed counters really well for the Micro800 line now, but let me know if you have any questions and maybe we'll do a video on it. You know, one thing I did notice while I was in here is you can do some basic servo applications with this. So we may see if we can get some parts together and see if we can program some motion control with the Micro800 series. If you'd like to see that, let us know down in the description. Till next time. Hey, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!